So let us solve some problems on kinematics from video model question paper program. Question paper. The first problem is like this: a car travels along a straight road. Its distance is given by the equation s is equal to 2.4 t square minus 0.12 t cube. So s is a function of t. That is, distance travelled is a function of time, where t is in seconds and s is in meters. Compute, number one, the average velocity of the car for the time interval t is equal to 0 and t is equal to 15 seconds. Number two, instantaneous velocity of the car at t is equal to 5 seconds. Number three, the instantaneous acceleration of the car at t is equal to 5 seconds. Of course, it's a simple problem. He has given s as a function of t here. S is equal to 2.4 times t square minus 0.12 t cube. So you know that ds by dt, the derivative of the displacement with respect to time gives the velocity, which is nothing but the instantaneous velocity. So if you differentiate this with respect to t, you are going to get 4.8 t minus 0.36 t square. So this is the derivative. Now using this we can find out whatever is asked. So the first one is asked average velocity of the car between the time period, the interval t is equal to 0 and t is equal to 15 seconds. So what I will do here is, I will calculate the velocity at t is equal to 0, that is the initial velocity before motion. So if you put t is equal to 0 here, we are going to get 0. So initial velocity is 0. Second value of t is equal to 15 seconds. If you need, put t is equal to 15 here. Velocity you are going to get 4.8 into 15 minus 0.36 into 15 square. So which you simplify, you are going to get minus 9. So you are going to get negative value, meter per second. Because distance travelled is in meters, time is in seconds, velocity will be in meter per second. So negative sign here indicates that the car has travelled from the initial position t is equal to 0 like this, but when the time is 15 seconds, so what happens, the car travels in the opposite direction, that is the meaning. So velocity is negative means, of course it is traveling in the opposite direction after 15 seconds. So that is the physical interpretation of that. Anyway, we are not worried about that physical interpretation. He has asked about the average velocity between these two time interval. So average velocity is equal to, so take the average of these two, which you are going to get 0 minus 9 divided by 2, which you are going to get minus 4.5 meters per second. So this is the first answer. The second one, instantaneous velocity of the car at t is equal to 5 seconds. So same equation we are going to have. We know that v is equal to 4.8 t minus 0.36 t square. So if you want instantaneous velocity at t is equal to 5 seconds, so put t is equal to 5 in this. So 4.8 into 5 minus 0.36 into 5 square, which after simplification you are going to get it as 15 meter per second. So 15 meter per second, that means, so you are getting the positive value, that means the meaning of that is when t is equal to 5 seconds, so it is moving in the same direction. That is the physical interpretation of that. Next, lastly, I have asked the instantaneous acceleration. So you know that acceleration is given by rate of change of velocity, that is dv by dt. Once again, you have to differentiate this with respect to t. 4.8 minus this becomes 0.72 t. So put if you want acceleration at time t is equal to 5, put t is equal to 5 in this, get the instantaneous acceleration. So which is a is equal to 4.8 minus 0.72 times 5. So at whatever time you have asked, you can just put the value of the time there. So if you simplify this, you will get 1.2 meter per second square. That is the unit of acceleration. That means it is positive acceleration means it is moving with increasing velocity with respect to time. So this is how, it is a simple problem. This is how once the relationship between the displacement and time is known, if if you differentiate once, you are going to get velocity, instantaneous velocity expression ds by dt is nothing but v, and once again if you differentiate v, dv by dt will give the acceleration component, that is the instantaneous acceleration component. This is one problem. So of course this problem of course carries 12 marks as given, but normally it may be for 6 or 8 marks. So model question problem. Now the second problem, so is also kinematics problem. It is from a different question paper, model paper. So the problem states like this. So understand the problem correctly. So understand the problem. I write the problem now. Second problem is like two cars moving the direction. Two cars moving in the same direction. Two cars moving in the same direction are 150 meters apart, or 150 meters apart. So the distance between those two cars which are moving in the same direction is 150 meters. Car A being ahead of car B. Car A being ahead of car B. Car A being ahead of car B at full stop. At this instant, that is at that time, that is the meaning. At this instant, velocity of car A is, velocity of car A is 3 meters per second, and constant acceleration of 1.2 meter per second square. While the velocity of car B is, is 30 meter per second, and its uniform retardation is 0.6 meter per second square. When and where they cross each other, when and where they cross each other. So this is the given problem. So two cars moving in the same direction are 150 meters apart. The distance between those two cars is 150 meters. Car B being ahead of car A. Please take this. Car B being ahead of car A. At this instant, velocity of car A is 3 meters per second and acceleration is 1.2 meters per second. So car A is moving with acceleration, while the velocity of car B is 30 meters per second and retardation 0.6. Car B is slowing down, that is, it is moving with retardation. The question is when and where they cross each other. That means when means at what time they cross each other, where means at what distance they cross each other from the point, from the car A. Let us take from the car A reference point. Now the solution, first we will understand, we will write the line diagram for the motion of the two cars. Since the cars are traveling along the same straight line, the linear motion equation can be adopted to solve the problem here. So let us write down the data, whatever data is given using the notations. So here he has given that car A, let me take car A is here at this point and car B is here at this point. The distance between these two is 150 meters. So car A is moving of course with an initial velocity of what you can say 3 meters per second. whereas RB is moving with initial velocity of 30 meter per second. That means at that time, at that instant, we can take that instant time when t is equal to 0. Now, car A is moving with an acceleration of 1.2 meter per second square, whereas RB is moving with retardation, which I can take minus 1. So it is minus 0.6 meter per second square. I have taken retardation as negative. So this is in the first at time t is equal to 0. Now the question here is, at some point, so these two cars will meet. So let me take the distance from this car B where they meet as x. X is the distance where car A and car B will meet. So this we know that this is 150 meters. So therefore the total distance travelled is 150 plus x. So total distance is 150 plus x. So this is the line diagram. Now we can take the motion of the two cars separately. Let me take car A, direction of motion of linear motion equation of car A. So if you write down the data for car A, u is 3 meter per second, acceleration is 1.2 meter per second square. Okay. So if you use and let us take that t is the time the two cars cross each other. That means now for car A is here, so this is the position for car A, and car B is here, this is the position for car B at t is equal to 0. Now for car A, the time taken by car A to cross car B is t. So that is unknown here, that we have to find out. When means that t is the unknown. Now we can find what is the distance travelled by car A. So this is the point where the two cars meet. Let us take this point only. So this is A, B, C. If I take C is the point where the two cars meet. So the car A will travel from A to C now. So A to C, the distance now is 150 plus x. So many meters. So this is the distance travelled by car A till it crosses car B. Now we know the equation of motion. S is equal to ut plus half at square. So using this equation, what I can write here is 150 plus x. X is 150 plus x for car A. U is 3, so 3t plus half into 1.2. A is 1.2 meter per second square, t square, which is 3t plus 0.6 t square. So let me take this as the equation 1. Similarly, I will write the direction of the linear equation for car, linear motion equation for car B. Here u is 30 meter per second, A is minus 0.6 meter per second square because it is retardation, it is not acceleration. So now, but the distance travelled by car B to cross car A is x here. S is equal to x here. Only this distance, this much distance it has travelled. And of course, time t is same. Now, what I can write the same equation if I use here, S is equal to ut plus half at square. Of course, A is negative here. S is x here. U is 30 t. T remains same because they should cross each other. So time remains same. Minus half into 0.6 into t square. So x is equal to 30t minus 0.3 t square. So this you can call it as equation 2. Now you have two equations. So equation 1 is 150 plus x is equal to 3t plus 0.6 t square. This is for car A. For car B, x is equal to 30t minus 0.3 t square. Now there are two unknowns, there are two t and x are the unknowns, but you have two equations, you can solve them. So what I do here is, I will eliminate one unknown here. To eliminate x, what you can do here is, you can subtract this equation 2 from equation 1. Subtracting, then x will get cancelled in the LHS. 2 from 1. So then x will get cancelled, 150 will be there. So this minus this I am doing. LHS minus LHS is equal to RHS minus RHS. So RHS here is 3t, here it is 30t, so it becomes minus 27t, and here this becomes plus here, 0.9 t square. So this is a quadratic equation. If you solve this quadratic equation, you can easily get the two roots. So here I can write this as 0.9 t square minus 27t minus 150 is equal to 0. So this is a quadratic equation in t. If you solve, by solving, of course you will get two values of t, out of which consider only positive value. You will get one negative value and positive value. Consider the positive value of t, you are going to get 30.54. Just do this. 30.54 seconds you are going to get. So that means the two cars A and B, they will cross each other after 30.54 seconds. So the two cars cross each other after 30.54 seconds. So this is when they cross each other, that is the term. Next, where they cross means we have to find out the value of x. So substitute the value of t in equation 2. So substituting for t in equation 2, we can get the value of x. X is equal to 30t. So the 30 into 30.54 minus 0.3 times t square, that is 0.3 into 30.54 square. If you simplify this, you are going to get x as 636.4 meters. Please check the values. So that means they will the two cars will meet at a distance of 636.4 meter from the initial position of car B. So I can write here it's after 30.54 seconds, the two cars cross each other at a distance of 636.4 meters from the initial position of column. So this is how we have to solve the problem. So you have to develop two equations, because when and where means t and x are the unknowns. Two equations you can develop, one for car A, another for car B, and two equations, two unknowns, solve them, you are going to get the required answer.